Hello everyone and welcome to the channel. If you want to learn machine learning but you don't have any coding experience, this video is for you. In this video, with only few clicks on RoboFlow, we are going to build a computer vision machine learning application that detects damaged packages in a pharma production line. So let's see how to do this. First thing you need to do is to go to RoboFlow website and create an account. Once you have created an account, you go to your workspace and then you create a new project. You select object detection. You give your project a name, damaged packages detection, and what we are detecting is damaged packages. And then you go and create a project. Now you can start selecting the images and upload them. We'll select all the images and we upload them. After uploading your images, now you can save and continue to start annotating the images. You can do manual labeling or you can do the auto one. So in this video, we want to try the auto label, which is the new feature of RoboFlow. So let's try this and see how good it is. So I have my first set of images is 95 images for packages that are damaged from the side. So we will give a name for this class or a label. So let's say damaged side. Then we can just give some description about the pictures or the label that we want to get. So we can say medicine images damaged from the sides, or we can say this is packages damaged from the side. Okay. Now, as you can see, the auto label model has labeled the images for us. Sometimes you can play with if you're not satisfied with the labeling, you can play with the threshold. In our case, I think this is good, the 50% confidence. You increase it, you will lose some of the labels. So 60 also I think is okay. Okay. So this is just for test images to check if you are okay with this labeling. If you are okay, then you can go and label the rest of the images. So we'll continue, start auto labeling. So this is going to take a while. Now, as you can see, 95 images have been successfully annotated for the damaged side packages. Now we will go and do exactly the same for the damaged top images. So let's do this. We go to upload data, select, we have damaged top, select all of them, and then save and continue. Auto label, damaged top, medicine packages, damaged from the top, and let's create the labels for the 4 test images. As we can see now, the 4 images have been labeled. I think it's okay. Maybe we can increase. Now we are losing some of the labels, so I think 50 is okay. Even if we decrease, it's not good. So I think 50 is okay. So we will just continue. We want just to see how well the model will perform using this new feature of the auto labeling. So let's discover that. And now also this will take a while. Now, as you can see, also 95 images have been annotated successfully for the damaged top. We have two sets of images, two classes, two jobs, two labels. And now we will go again and do the same for the intact side and intact top images. So let's quickly do this. As you can see now, another 95 images have been successfully labeled, which is for the intact top, intact side, sorry. Now let's go finally and add the, the intact top images and label them. Now, as you can see, we have 4 sets of images, 4 labels, 4 classes have been successfully labeled. Each set have 95 images, and one is for the damaged side, one is for the damaged top, one is for the intact side, one is for the intact top. So next step, for each one of these, we have to click on it, approve all the labels, and add them to the dataset. When you add them to the dataset, it will tell you that 70% of these images will be considered as a training set. As you can see here, 67 images will be used for training, 20% will be used for validation, so 19 images, and then 10% will be used for the test, so 9 images. So we are okay with that, so we add this. So as you can see now, 95 images have been added to the dataset. Similarly, we will do with the rest of the images. We are missing some labels here, but let's see uh, how well the model will perform, because the goal of this video is to try this new feature and see if it is really doing well or not. So let's see, proof all. For each set of images, we are missing some of the labels. Let's see, last one, approve all. Also, yeah, maybe we're not missing here a lot. Let's see, we are okay. And now we have our dataset ready to start creating the version, which is the model, and start training our model. So we go and create a version, continue. We will not change any settings. We will just continue the default one, and then we create. So now we have to choose the model that we want to use. So as you can see, in total we have 268 images will be used as a training set, 76 images for validation, and 36 images for the test. So let's train our model. We will use RoboFlow 3. Is recommended and fast and quite accurate. So let's continue with this one. There is 2 versions. This one is paid. This one is, but it's more accurate. But this one is fast and for free. So we'll continue with this one. We will keep the settings and we start training. Now, as you can see, training in progress. Okay, you wait a little bit. Now it will start showing the time, the remaining time. So as you can see now, the remaining time is 17 minutes. As you can see, the model is now learning the job, is being trained. So the accuracy or the precision is not really good at the moment, but the model is still processing the images, learning the job, and we can see that the precision and the performance of the model is improving with time. And let's see at the end of the training what will be the final accuracy or precision of this model. Now, as you can see, the training is finished. The performance of the model looks quite good. The precision and the accuracy is good. And now we are ready to try our model. We will try the model with images that have never been seen by the model before. So the original data was 100 for each of the 4 classes. I removed 5 images of each for this purpose, so we can test the model with images that the model has never seen before. So let's do this. Go back here. So this is the images. I have 20 images, 5 of each class. So let's try this, for example, and we see what is the prediction. So the model is saying it's 90% probability that it is damaged side, which is correct. Let's try another one from the top. Let's try this. Yeah, and the model is saying this is intact top, which is correct. So I will leave the dataset, the links for the dataset in the description of this video. Feel free to build your own model, to play with it. But this is not the end. You can further deploy your model in Python or any other coding language that you prefer. So let's quickly try to do this. So we go here, and then as you can see, it will give you the code using different languages. So let's try to do this in Python. So we copy this code. Yeah. So let's copy this code. We need to get the API key. So the API key. Yeah. So here we get the API key. So we copy this key. We put it here. And then also the model name and the version, we have to get this from here. We have the model name. And also the version is version 1. As you can see here, version 1. So version 1. And finally, we need to pass an image to get a prediction. So it's either to give the directory of your image or if the image is in the same file. So for simplicity, we will, so this is our directory. So we will get one of the images randomly from here. Let's say this one in the same directory of the notebook that we are using, which is this one. Let's get the name of this image. And we go back and put it here. If I think it's, yeah, PNG. So PNG. Now you can try the model. Yeah, so it's working now. It is giving the prediction as damaged side. To make sure that it's correct, we open the image that we passed, and it's, yes, it's damaged side. It is damaged from the top, but the picture is from the side. I think that is what is meant by the data set. Some images from the side, some images are from the top. So it's correct. So yeah, so you have this very simple code to call your model, pass any images, and get the predictions. And yeah, that's it.